my name is Donny Wals. I am an iOS engineer, blogger, author, today's speaker. I do workshops. I try to help people as much as I can to get better at programming through several different kinds of materials. And I also want to promote my books a little bit. I have a book called Practical Combine. It goes into Combine, and that helps you learn it. If you don't have the book yet, I have a 50% off code for everybody here today. Discount code Underdog Dev 2021-04. I'll keep the code active for about a month or so. So take your time to get the book if you're interested. The book isn't expensive. It's $30. So with 50% off, that's about $15. So that, in my opinion, is definitely a bargain for this book. And my other book is called Practical Core Data. It takes a similar approach to the Combine one, except it's focused on core data. Less relevant for today, but I still wanted to show it because the same 50% code applies. So write that one down, Underdog Dev 2021-04. And yeah, cash your discount. So let's talk about Combine. And the best way I think to talk about Combine is to show you, because the way that I like to learn is by doing and by seeing things happen. And presentations, slides, they're fun, but they're also a little bit boring, I guess. So let's go right in, and let's also, I've already turned that on. Clever me. Okay, so we have a little playground here and it's empty. And yeah, let's go into Combine a little bit. So if you've never heard of Combine, it's of course important. What is Combine? Well, Combine is a functional reactive programming framework. And what functional reactive programming is it's a way to respond to values over time. And responding to values over time is, well, it's pretty much, if you don't know what it is, it's a weird statement to make. So let's get into that a little bit more. What does that actually mean? And what does it, encompass for you as an engineer to respond to values over time? And the best way that I think we can think of it is, if you have an array of things, right? So we have an array and we have maybe some numbers in there. We can iterate over those, right? We can map over them and we can say, let's make that a string. So we can return something like hello, and then some integer right here. And then we have a new array, right? An array of strings, and we can print those. And what we have is it's a sequence. So it's a bunch of values that are delivered to us synchronously, right? We have this array, we loop over it to get values out of it. But what if we didn't have all the values immediately, right? What if these values would be delivered to us asynchronously? Well, in that case, it would be a little bit different, because we wouldn't be able to map in real time like this. We would have to have a mechanism to map asynchronously or map on demand. So imagine that you have the same array. Yes, Jess, I think you have a question because you made a noise. Or not? I guess not. Okay, so if we have this array of 1, 2, 3 again, and let's say we make that a publisher. And a publisher is a combined construct, and it's an object that will give us these values over time, right? In this case, what I've created here is a publisher, and it will take all the values in my array and immediately start delivering them. So what does that look like? Well, when you have a publisher like this, you want to receive the values at some point, right? You want to get them and do something with them. So we need a way to obtain these values. And what we can do is we can subscribe to a publisher. So we can say receive value or sync receive value, and that's going to give us an integer. All right, I can print that integer, and if I run this playground, you'll see that I have 1, 2, 3 printed in my console. So that's good. It's easy, straightforward, and it makes total sense, I guess. So when is this kind of thing even useful? Well, one thing that we can all think of that exists in a lot of apps is a notification publisher or a notification center. So normally you might say notification center dot current or dot, what is it? Default dot add observer, self, and then have some selector that should be executed. And which notification do we want to listen for, and any object that should be in there. I think this code looks somewhat familiar to most of us because it's the standard way to observe notifications. And this is a very good example of values that could be delivered over time, right? A notification could be emitted now, and then another notification could be delivered in 5 seconds, maybe in 5 minutes, maybe in 5 hours, we don't know. But at some point we might get a second notification. So we can actually translate this to combine really easily and sort of see what it's all about. So what I can do here is, instead of add observer, I can say notification center default publisher for a notification name. And I can really pick anyone, let's say keyboard related one, maybe. I believe that's on UI application these days. Yeah, there we go. Keyboard did show notification. Right, so anytime the keyboard appears, this publisher will send us a notification. Very similar idea, actually the exact same idea as maybe a more traditional notification center observation. But what we can do now is we can say, well, I want to receive these values in my publisher or in my subscriber. So this will emit a notification, and we can print that notification. And this looks really similar to what you would normally maybe write as a function, right? Notification received. And then you have your notification, etc. So this is the combined way of subscribing to combine publishers or to notification center events. And we can actually test this by having this subscription here and then say notification center dot default dot post, and then we can just create a notification here. So let's make one. Keyboard is notification, name UI application dot keyboard did show notification. And if we post this, and if I run this app, you can see that I now have an extra print here for the keyboard did show event. And all I needed to do was subscribe to it like this. However, in a normal app, this might not happen immediately. This might take a little while, right? So this works because it all happens synchronously. Now, if I would say dispatch queue dot main dot async after and do something like a second after now, I post this notification, then you'll see that nothing would happen. We can check that this was actually fired. And it is fired after a second, but we don't see a second print. And just to show you that we could get a second print, let's add one again here. So we see 2 prints, we see fired, but we don't see this one. And the reason this happens is because in combine, you need to retain your cancelables, is what we say. So what does that mean? Right? A cancelable is an object that sort of wraps this relationship between a publisher, which is this part right here, and a subscriber, which is our sync, which is created when we call sync. So calling sync creates a subscriber object and sets us up to listen for output from a publisher. However, as soon as that cancelable is deallocated, so it goes out of scope, it is no longer active. So in this case, the playground runs, right? And once we get here, the publisher is gone, or the cancelable is gone. And the reason it's gone is that just like in a function, if something runs asynchronously, the function might finish running, but it might still have some work going in the background. That's what we do when we do asynchronous programming, of course. So we need to change that. So let's do that. I'm going to remove that comment here, and I'm going to create another subscription here, except this time I'm going to store the cancelable. I say let cancelable equals, and I'm just going to do the exact same thing, except I'm going to print retained here. Retained cancelable, like that. See, so now we get 1, 2, and a third one, because we assign the output of sync to a property, and that keeps it around in memory. That makes sure the playground retains it, and it also makes sure that we can receive future events. So why is this good to know, and why is this useful? Well, first of all, I hope you see that this is actually kind of clean and kind of neat, because you don't need to have a whole class, you don't need to inherit from n as object, you don't need to have an Objective-C annotated function, you don't have to worry about all kinds of stuff. And this is just a much nicer way to subscribe, for example, to notifications. Now, earlier in the talk, I showed you map, right? I showed you that we had an array and that we could map over the array. And I told you, well, that's because all the values are delivered to us synchronously and we can go over everything one by one. And well, with that, we can very nicely transform an array of integers into an array of strings. And then I mentioned how a combined publisher is kind of like a sequence, but it's asynchronous. So we receive the values in an undefined amount of time. But we can also apply map to publishers because they are so much like sequences, or well, it's not because they are so much like sequences because it was implemented like that, but it was implemented like that because they are so much like sequences. So if I had go back up here to that original publisher, right? Let's make another one. 4, 5, 6. So what I can do is I can make strings again by saying array.map, and I'm going to take that integer and I'm going to say return item int. And so this on its own is not going to do anything, of course, and it's also an invalid redeclaration, obviously. There we go. So of course nothing happens now, and I'm going to disable the old print statements because otherwise the console is going to fill up a lot, and we don't need that. So nothing happens right now because what I have here is an idle publisher, right? This publisher is not currently emitting these values, right? 4, 5, and 6 are not immediately sent to the map because, like I said, in Combine it all is a little bit different. It's an asynchronous sequence, so it doesn't work just like a normal array. Because in Combine, a publisher will only emit values downstream whenever there's somebody listening. And a map is really in Combine just another publisher. And we can actually see that if we look at the return type here, because map returns publisher sequence generic over T. And T here would be the input or the output of our transformation. And that's in this case a string. So to get this stream flowing, we need to subscribe again. And let's be a good citizen and say, let string cancelable equals strings.sync receive value string in, and then we'll just print that string here. And now we see that we receive these items. And you can also see that this map, right? Let's check when this map is called. Map called for int. So when I remove this again, you'll see that map called for int is not actually called. Let's see, what did I do incorrectly here? Why are you unhappy about this, my playground? Well, okay. So you can see that this is called after all. That is very interesting. I did not expect that to actually print. But hey, I guess sometimes unexpected stuff happens. However, the map is still holding on to these values. We do know that because once we subscribe, we will still receive the strings. Boom. Okay, so that's sort of how we can map. But we can do a lot more with publishers than just take an output and then transform their output into something else. We can also use publishers to, for example, make network calls. And that's actually where things get really interesting. Because when you make a network call with Combine, you get a lot of convenience for free. And that convenience is mostly around error handling. Because I haven't talked about that yet, but because all of these publishers don't deal with errors at all. But a network call can fail, right? Something can go wrong. So we need to encounter, or we need to, account for errors. So what we can do normally, right? Let's write a normal little network call, and we call func fetch data, pass it a completion handler, and let's say that we also have a struct user, and that's a decodable struct, right? And that has a name. Very simple model just for illustration purposes. And so this completion is going to receive a result with either a user or an error, and it will return void. This should look somewhat familiar if you've dealt with network stuff before. Let's see, yeah. And we need to mark this as escaping because we're going to call this closure within the completion handler of our network call. So normally what you write is a little bit like this: URL session dot shared dot data task with URL. And then we'll just pass it some website. And force and wrap that, even though it's probably not an actual website. And what we can do now is get the data, response, and error. And now we would write a code a little bit like this: if error equals error, something went wrong. So now we'll want to say completion, call that with failure, pass the error. Then if we have data, then we'll want to decode that. So we'll create a decoder, and that's going to be a JSON decoder. And then we'll say, well, maybe the data contains an array of users. So we would say let users equal decoder dot decode user dot self from data. But this can fail, right? So we would prefix this with try. So let's write code for that to, properly handle this error. So if we encounter an error here, we're going to say completion, failure with the decoding error, and otherwise we'll say completion dot success and pass it to the users. So this is quite a bunch of code. And I want you to sort of look at this and realize how much of this code is really just error handling, kind of pointless boilerplate almost, right? This is solely for error handling. This is basically just checking that we have a success. If we don't have an error, there is kind of no way that we're not going to have any data. So this is completely unnecessary. Then we have this part right here, which is also error handling. And then we have this line, which is also related to, doing something that can fail. Now in Combine, we can do a lot better. So I'm going to write another function and call it fetch data. And for now, I'm not going to give it a completion handler or anything because we'll sort of roll into that next. So what I'm going to do is I'm going to again use URL session.shared. What's really nice is that Apple knows that networking can be made much nicer with Combine. So they added this special function here, data task publisher for URL. So we can just pass it that exact same URL. And we can then say map, for example. So the output of a data task publisher is going to be either a tuple of, let's see if I can quickly click through to that. Yeah, so we have data task publisher output, which is a tuple of data and response. And we have data task publisher failure, which is a type alias for URL error. Right, so we'll either get a tuple of data and response, or we'll get an error. And what's really nice is that if something goes wrong in Combine, it is immediately passed to the subscriber. So if you subscribe to this publisher, you can get a completion handler or you can get a value. And a publisher in Combine always completes exactly once. And it does this either successfully or with a failure, or it never completes at all. And we'll get to that in a second. Everything we've seen so far, except for the notification center publisher, completes. But I'll talk about completing in a moment. But so receive completion is going to receive either our error or a successful completion. Right, so we'll do completion in if let if completion, case let dot failure error equals completion. I believe that would be the syntax. Then we could print the error right here, right? And otherwise we'll print success. So that's how we would deal with error handling here. If everything went well, then we would have this tuple right here. We'll have an output and we can print that output. Now this data right here, that's a tuple. That's what I told you, but we needed an array of users. So what we can do actually is we can say map over this. And our map, as you'll see, it receives this tuple. It does not concern itself with error handling at all. If this data task publisher fails, everything we do after it is omitted and we go straight to the subscriber, which means that we don't need to worry about error handling in our maps at all. So I can just use Swift's key path mapping, which is new, I believe, in Swift 5, and just do /.data. So this will extract the data from our response and forward that down. So right here, this output right now, it's data. It's no longer that tuple. And to decode my data into a user, I can do this. I can say decode user.self using just a regular old JSON decoder. And now my output is an array of user. This is really nice. Like I can subscribe to this here, but that's not equal to this, right? Because this one I would call by saying fetch data. And then I have my completion handler, which will receive a result in, and then handle the result. So what I would want to do here is call this flavor of fetch data and then receive the result. So I'm going to get rid of this sync right here. And what I want to do is this, fetch data dot sync and then handle stuff. So what I need to do here is I need to return a publisher from fetch data. And to do that, I can use a construct called an any publisher. And the reason I want to do that, I'll show you that first before I talk about any publisher. The reason I don't want to return this as I have it right now, is because if I would return this publisher, here's what I'm returning. I'm returning a publishers.decode generic over publishers.map keypath generic over URL session.data task publisher, something with a JSON decoder.input and user array and a JSON decoder. Now, I don't know about you, but this function signature to me, there are not a lot of things that I would hate more in my code base than having to type this all the time. So instead of typing that, I can say what I return here really is just a publisher. Any publisher, you shouldn't care about what kind of publisher it is. It's just a publisher. Just trust me. It emits an array of users, or it fails with a generic Swift error. Of course, this says return publisher cannot convert return of expression publishers decode, etc., 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 to any publisher. And to fix that, I can type erase to any publisher, and that will sort of simplify my publisher type and hide the internals inside of an object called an any publisher. And so now you can see that the code in fetch data, right, they're now equal. They both make a network call, extract data, decode the data, and let the caller decide what to do with the output. The only problem here is that I needed to forward an error. And actually, there's a bug in this code too, because what happens if, and it is theoretically impossible because it shouldn't work like that, but what if both data and error are nil? We would never call our completion handler. That's kind of a problem. And it's easy to make that mistake when you forget to handle some edge case or some improbability that you didn't account for. Here, on the other hand, we just have our publisher. If that fails, we immediately nope out. We don't even get to the map. We just throw that error out there and it's immediately passed to this completion. If the decode fails, same story. We just immediately bubble the error into the receive completion and that's it. And if everything goes well, that's good. Then we receive the value, the result right here. So that's how Combine could refactor your network calls. Now, if I run this, we're probably going to see failures and problems and all kinds of stuff that we don't want to see. Actually, we're not even actually going to see an output because you know what I did. I forgot to hold on to my cancelable. Because again, a network call is asynchronous, so it doesn't complete in real time, which means that if the network call completes, then, if the playground sort of runs, then the network cancelable would be deallocated if we don't hold on to it. But this is what I expected, right? We received a URL error. We got to this point right here because the server with the specified host name could not be found. Makes total sense to me because, I totally made this up. And if you're looking for a side project and you want to build some website, apparently somewebsite.com is available, I guess, or at least not found. So I've been talking for about 30 minutes now. If you have any questions or anything in Combine that you want to see or that you want me to talk about a little bit, feel free to raise your hand. The moderators will sort of ask you to unmute your mic and you can ask questions. Because of course I'm not here for me. Like, I love showing these things, but I'm also here for you. So I want to make sure that you get what you're looking for. Okay, so earlier I mentioned something about that I would talk about publishers completing. And as I said, publishers complete exactly 0 or 1 times. This publisher right here, it completes once because it makes the network call and then it completes either successfully or with a failure, and it emits exactly 1 value. And not every publisher is going to emit exactly 1 value, because earlier we saw that example right here of the strings publisher, right? This publisher emits 3 values. And I'm not listening for a completion event here. And I don't have to, but I could if I wanted to. And the reason I don't have to is because this publisher can never fail, right? It doesn't have an error type. If we look at it, we see that it's a sequence publisher of integers, and it has never as its failure type. So in other words, it cannot fail. Therefore, you don't necessarily need to implement receive completion if you don't want to handle the errors. If we do want to handle completion events, we can say receive completion, completion n. And you'll see that if I print that completion here, you get 1, 2, 4, 5, 6 finished. And that's because we finished successfully. This publisher is now done. Now, if I would do the same right here for my notification sender publisher, I could say received completion And if I print that completion here, you'll see that I have an incorrect argument label, obviously. Receive completion. And so you'll see that, well, let's add this back. See that my retained cancelable is printed. It's printed again. But we don't see that finished event for, or the second finished event for this one. So we see this first one right here, which is the one that I printed from here. But that other one, we don't see it. And that's because this notification center publisher, it never completes. And that makes a lot of sense because, well, as long as your application is active, there's a chance that a notification center publisher will publish an event. Now, what are some other publishers that might not complete ever? And that brings me sort of into the realm of things like Swift UI, where we deal with publishers that don't complete all the time. Consider this, this model. I'm just going to call it view model, even though we don't have a view. And if you've ever written Swift UI, this probably looks a little bit familiar to you. Right? You might even write a little view here. And have a state object. Let's import Swift UI. That little state object of view model and a var body, some view. Maybe you have a VStack in there with a text field. And maybe you've bound that text field to your view model dot name. Ah, yes. And then we do this, and now this should be happy, yes. And we can actually show this view into Playground by saying playground dot or playground page. Let's first import playground support. Playground page dot current dot set live view, and that will be a new instance of my view. This you may have seen in your combined apps where you have this name thing and you can type in it and it updates, right? We could make this a little bit more clear by saying that we also have a label that just shows vm.name or text. I don't know why I thought of a label for some reason. So if I type here, you'll see that this thing underneath, it's not very clear. I wish I could drag this to make it bigger, but hey, you can't have everything. But you can see that sort of every time that I type something in that text field, that this little square right below there, it also updates. And this is all powered by Combine. And we can actually sort of see if we can mimic this, this my view using just subscribing to stuff. So if I have an instance of my view model here outside of the view, so what Swift UI does is Swift UI actually listens to this, right? It says vm.objectWillChange.sync. And that's a publisher that emits void values. So all it does is it acts as sort of a notifier. And it emits right before the object changes. So whenever we assign something to the name of this view model, this publisher will emit. So I could subscribe like this. And I could say vm.name equals hello. There we go. You see, emit it. So that worked. I'm also going to remove this print, by the way. That's cleaner. Right. So we can see that this playground or this object will change publisher emitted something. We can also, and that's far more interesting, say vm.$name.sync. And this will emit the new value of our published property. And SwiftUI does not subscribe to these published properties directly. Instead, it subscribes to the object will change, because object will change emits whenever one of the published properties changes. So this is much more convenient for SwiftUI because it allows SwiftUI to subscribe to everything instead of subscribe to everything individually. So you'll see new value, hello. And this publisher also never completes because it remains active for as long as the object needs to be around. And when the object is deallocated, the whole thing is just torn down and the publisher didn't actually complete. So that's sort of the published property. And we can use this to our advantage by building something far, far, far more complicated. For example, let's say that you wanted to build some kind of observable object. And this example is, it's a little bit silly, but it's going to be a count words, count letters thing. And it's an observable object. And it has a few properties, right? So it would have a published var field 1. That's just going to be an empty string. And another published var field 2, which is going to be an empty string. And it's going to have a published var number of letters. So what I'm going to do is I'm going to use the power of combine in this class to get the number of letters combined in field 1 and field 2. So I'm going to write a little initializer here. And what I'm going to do is I'm going to combine these two publishers into one publisher that emits both of these values. Before I do that, I'm going to use combine to only subscribe to one of these publishers. And then I'm going to combine them into one, or combine both of these into one. So we'll start with only getting the count of field 1, right? So I'm going to say field 1 dot map, right? Because $field1 is a publisher, so I can map over its outputted values. So I'm going to say string in, because it emits strings, since that's the type of value that field 1 holds. And I'm going to map that into an integer. So I'm going to say return string dot count. So if I would subscribe to this in a sync, I would receive an integer. Right, you can see sync receive value gets an integer. And what I could do in theory is I could say self.number of letters equals int. And that would update this published var, and it would allow me to get that. So let me show you that if this compiles. Compile, it does. So I'm going to say let thing equals count letter thing dot dollar number of letters dot sync receive value number and print. We have number letters. Okay, so this pattern here should start to become a little bit familiar by now, right? We have a publisher, we want to get its values, so we subscribe to it, and we don't forget to hold on to the return cancelable. So if we do this, we have 0 letters. That's because this publisher here will immediately emit its first value. Now, if after this we say thing dot field 1 equals Donny, we'll see that we get did I not update? Did I not write that correctly right there? Ah, yes. So anybody facepalming and saying, he forgot to hold on to his cancelables again, good job, because you've spotted my mistake before I did. So another way to hold on to cancelables is to create a set. And we can then say, whenever we subscribe to a publisher, we could call store in on the returned cancelable and pass our set of cancelables. So this will also retain our subscription. And now you can see that we immediately get this. We have 5 letters. And the reason we get that immediately is because we subscribe after I assign the new value. So if I subscribe first and then update the value, you'll see that we get first 0, then 5. And if I change this, it will get 0, 5, 4. So this is pretty neat, but I don't like this. I don't like subscribing to publishers to update other publishers if I don't have to. And Combine actually comes with a very neat other method of subscribing to a publisher that only works if we want to or assign the value or the output of a publisher that cannot fail, like this one, to a published property. So we can get rid of this. And we can say field1.map to create some strings.assign to, and then we can pass this publisher, this number of letters publisher, as an in-out parameter to assign. And this will automatically pipe that output into the published property. So if we run this again, you'll see that the result is the exact same. So this is a nice way in SwiftUI, for example, to take the output of some things and then update your view. So let me show you that real quick. So what we can do here is we can say, copy this over here, and I'll just name this my thing view. And the thing view gets the count letter thing as its view model. And the name right here is going to be bound to view model field 1. And the text is not going to be the name this time, but it's going to be VM number of letters. And what you'll see here is that now, whenever I change something in field 1, you'll see the count underneath it change. Let's rerun that playground. There we go. See, so this gives you the number of characters in my view, and we can use combine to do that. And in fact, I made this published property only so I could use this convenient assign to, because we're not changing this directly, so SwiftUI doesn't need it to update the view, but it's still a nice way to, re-render our thing and get the number of letters.
Can I make a comment?
Yes.
Is that a way to avoid the modifying view during state update, or modifying state during view update thing?
No, not per se. No, because this would emit before the value changed. I should be able to assign or update multiple published values without running into that, as long as they are all updated like synchronously in the same sort of run loop step, basically. If I would assign them after SwiftUI tries to update, then we could run into issues. But I haven't seen issues with not using assign to and just subscribing, for example, here.
Okay.
So as far as I know, not really, but also maybe. I'm not 100% sure. I'm like 99% sure. Okay, so if we would add field 2, so I'll just name 2. Right, and we run this, then we can type here and we see this updating. So how do we make it so that if we type here, we also update and we get the sum of the length of both of these fields right here in the number? So what we can do is we can use one of Combine's combination publishers. So we can say publishers dot, or publisher, let's first fix that little typo there. Publishers dot, and then we can, there's a whole lot of publishers in Combine, by the way. Like you can see here that there's a ton of different publishers, and we are interested in the Combine latest publisher. So that will take the latest output from each publisher as soon as each of them has emitted at least one value, which they both do immediately. And it will send both of these values downstream. So let me show you that. So I can take field 1 and field 2 here and combine them into one publisher. Then I can map over that publisher, and instead of one value, I receive a tuple. Right? And a tuple, of course, has no member count. So what I can do here is I can say return strings dot 0 dot count plus strings dot 1 dot count. 0 would be the first element in my tuple, 1 would be the second element in my tuple. And I believe we should be able to also make that a little bit more readable by saying 1 string 2 string here. And now we should, because now we've defined the tuple and we've named the arguments, and we should be able to do this 1, 2. Slightly more readable, I think, but it works. And this is all we need to do actually to make this example work. So if we type here, we get up to 3. And if I type more, we get up to 6. So this is one way where, it's a very simple and trivial example where you can use combine and things in combine to actually update a different property in your model and then update your SwiftUI view without putting any of this logic, because that's really all you gained here. There's no extra logic in your SwiftUI view. You have all your logic in that view model object, and it's all nicely separated. So the SwiftUI view only knows how to present things, but it has no idea how number of letters is calculated. I kind of like that personally. I know not everybody thinks that's necessary, and you can have a whole discussion about app architecture to see what works and what doesn't, but I like this. So I figured I'd show you this too. Now there's one last thing that I want to talk about, and that's more networking related stuff, because networking is a really good example of showing off things Combine can do. And in Swift, you may have heard of the flat map operator, right? So we could have a source array in Swift, and that could be, some numbers. And then we could have a mapped array, and that would maybe be source array.map int n, and we could return another array, right, of int times 3 and int times 4. And if we print mapped array now, you'll see that we have this array and it contains 3 nested arrays. Now, if you would want to do this, but you don't want to have nested arrays, you would use a flat map. Right, so flat map will flatten the array. It will remove one layer of nesting in this case, and you'll get this, an array of 9 elements, 1, 2, 4, 2, 4, 8, 3, 6, 12. Now in Combine, we can do something similar, right? So if I would say let array publisher, or yeah, let's just call it, what do we call this one? Let's call it 9 publisher, because we're going to count up to 9. 6, 7, 9 dot publisher. Right, so if we have that, and we would flat map, or we would want to create new publishers based on this publisher, right? Just like how I just created new arrays based on that initial array. I can say 9 publisher dot map. Let's start with the incorrect solution. If I would then return, and let's just make this exactly the same example, right? If I do this, and then I say sync value in, and I print the received value, you'll see that what I get is this. And what this is a sequence publisher, right? Because I have my publisher that emits integers, just like I had an array that contains integers. I map over it, and I return a new publisher that contains integers. Just like earlier, I created a new array that contained integers. If I don't want this, which, this is arguably not very useful, I can also switch to flat map. And when I flat map over a publisher's output, I can return a new publisher, and then the output of that publisher will be flattened into the stream of outputs. So you'll see that now these values are all printed. And this at first, for me at least, was a little bit mind-bending, because it's like, why does it look like that? Why does it work like that? But I keep coming back to this array example, right? If I have an array, and for every element in the array, I return a new array, when I flat map over it, I'm going to have one array with all the values in it. So if I translate it to a publisher, if I have a publisher that emits elements, if I transform the element into a publisher in a flat map, then all the elements emitted by that new publisher are going to be woven into a single stream of values. And you're probably going to have to repeat that to yourself a couple more times and come back to this example with a normal array and then a flat map array and then, or flat mapping over an array publisher, and then you'll sort of get it. So I mentioned networking when I started this, this little explanation, and I found that this flat mapping can be really useful in a networking situation. So for example, imagine that you have a network call, and that network call would return to you a list of 5 URLs. And from those 5 URLs, you would have to load the images. Just some random thought. So if we make a publisher, right, URL session shared dot data task publisher with for URL string. And actually, you know what? Let's make this a little bit more fun. I actually have a URL for you, but I just need to find it. So I'm going to go ahead and look up my little URL right here, and we're going to use this one. There we go. Boom. And this should, yeah, this should look good. So this is a little JSON file with 2. Let's make that 5. Right, that still works. I think it does. I know 4 works. Let's keep 4. So we're actually going to make a real network call here. Make a little bit more room on the screen like that. So like this. Okay, so we have our data text publisher for URL, and let's subscribe to this and inspect what we receive from this URL before we move on. So I'm going to have the result here, and I'm just going to say string data from result dot data encoding UTF-8. And what did I just do wrong? That's right, that's right. Ah, yes, underscore n. Okay, so we need to print this. And we should ideally eventually see something, or maybe not. Is there a mistake in this URL maybe? I don't think there is, but no. Let's see, data disclosure for URL. We have this, we have that. Ah, I know. Playground page dot current dot needs indefinite execution equals true. Or is that not the issue? Now I'm a little bit worried what might be our problem here. Is this just being very slow? Let's give this a second. Otherwise, I'm just going to continue on and pretend that this worked, because I would just want to show you the flat map really.
Is it a retained cancelable thing?
I think not, because I'm retaining it right here. So we should be good. Just wondering what the issue could otherwise be, because it does look like it, but it shouldn't be. Let's just very quickly make sure that nothing else is in the way. Retain this, we print that. Let's try with a slightly different URL. Okay, we have a working network call in here somewhere. I just want to test that that is all working fine. There, this print. So that one is still working. So why is the other one not working? What am I doing differently compared to that one? Not a lot, actually. Okay, you know what? I'm going to go ahead and reuse that initial example because I know that works.
We did have a question.
Oh yeah, let's do the question and then we'll move on.
And if I can find him again, I'll unmute him. You should be able to unmute.
Not exactly a question. I guess you is missing the resume.
No, it's not missing the resume. No, no, we don't need resume in
okay. This is
Good
new
suggestion
for me.
though, thanks. As far as I can tell right now, the issue seems to be with the URL actually, because when I reused this exact same code right here. So I'm starting to think this is more of a Playgrounds issue than it is a me issue. Okay, so anyway, we'll just pretend this works and I'll just go through the code. Because really it will be cool if this worked, but if it doesn't work, that's fine too. So normally this would output, data, and we would have a model that looks a little bit like this. It just has a property URL, and that could be a string. So we would get something like this back. And so we could take the output from this URL and the JSON, let's just throw that into Playground real quick. So you sort of have an idea why I am writing the code that I am going to write. There we go. So this is sort of what it would return, right? An array of stuff. It has a row property, call property, and a URL. And we are only using the URL. So that's why I am defining the model like this. Okay, so we can do the same thing we did before. Data is what we want to get. So we map, right? Use the key path notation to extract data from our return tuple. Then we can decode. So we're going to decode into an array of image dot self using a normal JSON decoder. And okay, so at this point we have that array of images. Referencing that on array. I'm not referencing that on array, I think. Ah, yeah, okay, that makes sense. The image has to be decodable. We'll get rid of that for now. Okay, so this compiles again, that's good. So we now have at this point, so if we would map over this, we have that array of images. So what I'm going to do here is I'm going to say flat map, right? Because I want to do something with that array of images. And what I want is to transform this array of image structs into single entries so that I can then create a new network request for each individual URL. So what I'll do is I'll say return images.publisher, right? And then if I would map here, you'll see that I have an image, right? So this is the output of a publisher.sequence of an array of images. And we know that whenever we have that, what we'll get here is going to be a single image. And what we can do here is instead of normal map, we can flat map again, because what I want to return here is another publisher, and that will be another data task publisher. So we'll flat map over image and we'll say return. Just add a return here too, by the way. return URL session.shared.data task publisher 4, and then we'll create a new URL with a string initializer, and the value for that will be image.url force unwrap. Okay, so this would just return a new version of our tuple of data and response, or it would fail. No exact matches. I'm pretty sure you'll find a match. Or you should. Yeah, okay. So the Swift compiler tends to get a little bit confused when you start flat mapping stuff. So we're going to add a little helper to it right now. So what we'll do is we'll say we'll take an image and we'll return an any publisher. And that any publisher is going to emit a UI image, or it will fail with just a generic Swift error. Okay, so what we have at this point is we have a publisher declared it's incompatible. Yeah, we'll get there. So what we have here is we have that array of images, then we flat map over that array of images, returning a publisher that will emit each image individually. So this flat map will get each individual image. We can then make a new network request for that image URL. And what we want to do now is we want to map. And actually, we're going to return an optional image. So we'll map. And here we'll get a response object, right? So that's that tuple of data and URL response. And we'll say let data equals response dot data. And then we'll say that we'll return a UI image based on that data. And that's an optional initializer, so that could return nil. So here too, we'll add a little helper URL session.datataskpublisher.output, and we return an optional UI image. So what is currently frustrating the compiler? Is it really complaining because it wants us to move this in there? Ah, yes. And of course, because we didn't erase any publisher yet, we need to do that right now. Okay, and the failure type doesn't quite match up. So this can be a little bit annoying in Combine when you really need to carefully match all of your failure types, because this publisher right here, the data task publisher, can fail with a URL error, which is not necessarily a Swift error, or it is, but Swift error is less specific. So Swift wants us to be hyper specific here. Okay. Instance maximum requires the type URL error never to be equivalent. Okay, so that was the issue all along. So what we're running in here is, what we see is that this publisher never fails, but this publisher can fail. So what we need to do is we need to say set failure type to URL error.self, and this will assign a failure type to this publisher, even though nothing can fail. So now if I go here, does it finally compile? This always happens whenever I decide, let's try this, it'll be fun. Off script, we'll always see that things go a little bit weird. Okay. So let's do a little bit of live debugging here. Instance member flat map requires that URL type and never be equivalent. Okay, so we can fix that by saying set failure type to URL error.self. No exact matches to call instance flat map. Oh, but there is. We'll just have to tell Swift exactly what we're doing. And we return any publisher. You can see how quickly this is sort of turning into a lot of specific code and still no exact matches. But Why is there still no exact match? Okay, let's back up a little bit. Let's use images and let's return images publisher. If we would subscribe now, we would be all good. Right, but this would return. Hold up. Why is this giving us? Oh yeah, okay. So this is giving us a single image. So this is exactly what we wanted. Now if I flat map over this, and let's just say, well, let's just normal map for a second. I'll just map, return. No, I do want a flat map, and I want to return image in, and I'll just return image.url. So this still works fine, and we don't need to flat map here. That makes sense because we don't return a publisher. Okay. So this, whenever I debug something in Combine, I typically tend to like write it out as verbose as I can, and then I might try to make it smaller again afterwards. So actually, let's change this a little bit and say URL string. Okay, so now this flat map will receive a URL. And so in this flat map, we're going to return a new publisher then. Instance methods flat map requires, okay, that's maybe because I didn't write this out just yet. Just return URL session.shared data task publisher for URL. Cannot find that. Yes, that makes sense. Data task publisher for URL. No exact members. So this is confusing me right now, and I'm starting to think that this is not the first time the playground has bitten me on this kind of thing. So what shall we do? Shall I continue to keep trying this, or do we feel like we sort of get the idea, get the point?
Well, actually, we're a little over time, I think.
Yeah, that's exactly what I'm thinking. Like I'm fine to try and keep this working if everybody wants to see that, but I'd also happily take some questions. Maybe that's more productive.
Yeah, why don't we open the floor to questions?
Yeah, let's do that. Yeah, but anyway, this is the idea, right? You can get an output, transform that into a new publisher with flat map, work on it, continue to flat map on things, and eventually you could build like a whole complicated stream of stuff. I am going to share this playground in a GitHub gist, by the way, and I'll double check why this isn't working later and make sure that I either add a comment or have a working code in there. Let's do that.
Awesome. So I'll start with a question.
Cool.
Why would you use Combine versus a Swift UI, just observable object?
Right, so it's typically best to use a combination of the two, right? So what I showed here earlier in this example, and it's a bit of a silly example, just because I wanted to make something that is explainable in a short time frame. Mm-hmm. But so what you can do is you can use Combine sort of to manage your networking layer, your data layer, and all that kind of stuff, and be reactive there. And then eventually update things on your observable objects. So in this case, the sort of external factors are the field 1 and field 2. Those could also be database related publishers, for example. And then eventually you want to update a published property so that SwiftUI can see that property and do something with it.
Okay, cool.
It's for sure not a either or. It's definitely a use both.
Right. All right. And then Parth has a question.
Perfect.
Hi, Donny.
Hi, Parth.
Hi. So Donny, I have a question that combine is kind of a work on the pub sub concept, right?
More or less, yeah.
So at what kind of applications one developer should target combine using the combine framework? Like there are MVC, there are MVVM architectures available in the market. So at what kind of different architectures or kind of scale of application where combine is much more helpful to the developer? Like
Yeah.
say if I'm just making a small application, then learning the combine making that kind of side project is not practical thing. So what kind of side projects do you suggest?
Yeah. So combine shines most if you have an application that processes sort of this values over time idea that I mentioned at the very beginning of this talk. Values over time is a concept that's basically sort of all encompassing for stuff like data that changes over time or things that happen during your application lifecycle. So if you deal with data that changes a lot, for example, that makes a very good combined use case. If you have these very complex error handling kind of things, like I showed in this example here, where the non-combined code is more than 50% just handling errors and calling completion handlers, you want to get rid of that and you want to use combine instead, so that you can clean it up into something that looks more like this, which is much more to the point, like make an API call, get the data, decode it into an array of users, and then give back a publisher so that I can subscribe to it and do only the minimal amount of error handling without ignoring any errors. That's also very important. And in terms of architecture, like it can be used in any kind of app, like MVC, MVVM, Viper. It works with all of them, but I've found MVVM to be sort of the most flexible and most suitable architecture to start weaving combine into.
Awesome, thank you. Do we have any other questions? All right, well, I want to thank you so much, Donny, for coming on and presenting with Underdog Devs. We really appreciate your time and your wisdom.
Yeah, my pleasure. Thanks for asking me.
Yeah, and for those of you out there, follow Underdog Devs on Twitter and follow Donny too. Donny, do you have a Twitter handle?
I do. It's just my name, Donny Wals.
Donny Wals with one
Yes,
L.
with one L.
Awesome. Well, thank you again so much. Great presentation.
Thanks. I hope it shed some light onto combine for everybody.
Yeah, thank you, Donny. We really appreciate it.
Thanks, Rick.